And welcome back. Now today we're going to be talking about this little collection of modules here, collectively known as the Home Alone project, otherwise perhaps known as Vulnerable Person Monitor, because my mum asked me to make this, would you believe, and she knows nothing about technology, but here we are. And during the course of creating all this, I designed, or created at least, that PCB at the back there, and this one. And this one is in fact a 4-layer PCB, indeed. Don't get too excited though, it's about as simple as a 4-layer PCB can be and still be called that. First things first then, Home Alone project, what's it all about? Well, a number of you have written to me in the comments, because I've mentioned it on and off. We've had a few videos about various aspects of it over the last few weeks really, and months. And I've sort of hinted at what it might be, but we've never actually gone into any great depth, mainly because it's just a big project. And even though you might think, well, there's only a few components on here, what could be so difficult about it? Well, let's start at the beginning then, shall we? So it's firing up even as we speak, connecting to Wi-Fi. When it does that, it goes to the network time protocol servers and grabs the time. And then it says, okay, everything's fine. I'm monitoring according to all the parameters on that SD card in there. So for example, I'm uploading to the cloud every 15 minutes or thereabouts, and the 15 minutes is a parameter that's on that SD card, as is the ThingSpeak URL, the ThingSpeak channel name and stuff like that. Now if you've never heard of ThingSpeak, you really ought to get into this, because it's IoT at its very simplest, and it's free and easy to do for beginners. Now we've talked about it a little bit before in previous videos, but this time we'll just have a see what exactly I'm doing with that data and how it's helping my mum over in Germany, hundreds of miles from where I live. Okay, more about all this and a very special offer from JLC PCB after this. I want to have a big shout out for my sponsor of this video, JLC PCB. Custom PCBs made simple. Now I've just ordered some PCBs and they've arrived a couple of days ago. It took about 3-4 days for them to arrive. I chose the DHL shipping option because it was nice and quick. Let's have a look on the order page, see what it looks like. So here we are, these are all my orders, and there's the order that we're looking at here. This one here, this is the PCB that arrived just the other day. Brilliant, excellent quality, nothing I can say about it except good things, and we'll be looking at this in a future video as I build up a little circuit. So remember, it's $2 for 5 pieces, $5 for 10, quick shipping, but there are many options you can choose from, quality second to none. Why don't you try them out now? Now the special offer from JLC PCB is if you send me your username, that is the one you've registered with jlcpcb.com, I'll forward those on to my sponsor, and you'll get $5 off your first order. Now the prices on JLC are $2 for 5 boards, $5 for 10 boards, but each of those is plus shipping, so you can't have 2 lots of 5 and think you can get a better deal. All right, and the shipping is the bit that costs the money, as you can imagine, from China. I use DHL most of the time, and that costs around about $20. And there's various other options. You have to go onto the website to have a look that I've just shown you and make your own mind up. As I say, send me your username and you'll get $5 off your order. Right, now I'd like to talk about the 4-layer PCB, but we'll leave that for a little bit towards the end of the video, because this video is really about the Home Alone project and what it's all about. Now there's a formal description I've put together, so if you're into formal descriptions about how it all hangs together and what each of these little modules, plug-in modules, do, as you can see they all plug in, look, all got little things on them. That's coming up next, but if you want to skip that, go to the time on the screen now, and we'll catch up with a bit more generic information. Right, here's a very quick overview then about what the Home Alone system that I'm building for my mum really consists of. And as it says, it's an ESP8266 solution. Fine, what does that mean? Well, the Wemos D1 Mini is at the heart of the system. The D1 Mini, as its name implies, is small. Lots and lots of different types of shields, and if there aren't ones available there to buy, you can make your own. So that's pretty good. But that's not the only reason that I chose this. Number one, I chose this because it's got Wi-Fi built in. Without that, I couldn't upload stuff to the ThingSpeak IoT repository, so that was a no-no, so I had to have something with that. Otherwise, this would all be done on an Arduino, quite frankly. Secondly, I needed a fast processor because there's quite a bit of stuff it's doing. 80 megahertz. The ESP8266 can run at 160, but I don't know if that's supported. It's just a hack. But anyway, I'm keeping in mind at 80 megahertz for now. Many times faster than the Arduino, I might add. And it's got quite a few GPIO pins available. Unfortunately, rather fewer than I thought perhaps it would have, but there's still quite a few, and I've managed to use them all up now. So I hope I don't need any more for that. And finally, it uses the standard Arduino code and IDE. Now, as it uses the standard Arduino code and IDE, it means that millions and millions of people can use the ESP8266 pretty much as they were an Arduino Uno or Nano, whatever. And it's a no-brainer, quite frankly. So yeah, let's stick with that and see how far we get. Now, apart from those main reasons there, what other things do I need around this supporting infrastructure, if you like, to make this work? Well, because this is movement based, the first thing I'm going to need is the PIR. Now, the PIR is small, as you'll see in the actual technical stuff in a minute, and it delivers a pulse whenever there's movement. The pulse goes high for about 2 or 3 seconds and then goes low. So if you wave your hand in front of the sensor, it won't detect 10 movements. It's 1 until you stop and there's been no movement for, as I say, 2 to 3 seconds, and then the pulse goes low again, which is great, exactly what I want. Now, we do need a delayed startup though, precisely because of that. The pin to which the PIR is connected on the Wemos has to be low in order for the Wemos to boot. Well, when I designed all this, I just was picking pins at random, really. So having picked the wrong pin almost, there just weren't that many to choose from, I can tell you. But the one I picked, if that went high, the Wemos wouldn't boot. So I've had a delayed startup, only about a second, 2 seconds, well, 1.5 seconds, something like that, just to make sure the PIR doesn't work immediately upon switch on, to give the Wemos time to just spring into life, and then it's away and then it doesn't matter. So a little tiny delay startup. Now that was easy enough. All that required was a capacitor, a resistor and a transistor, and it was easy to do. That'll all be shown. What else do we need? Well, we need that SSD 1306 OLED screen. That's very nice, and it's been an absolute lifesaver for this. And it comes on a little tiny shield that you just plug in all by itself. You can see details of a very similar one in video 141. The touchpad we covered in video 143, absolutely goldmine that is. It's so easy, and it's a capacitive one, and it's self-adjusting, so that you can put things between it and you, and sensor panels and all that, and it just works basically. You really have to watch that video. Now we need an exit, a movement beeper. We don't need the movement beeper. That is to say, when the PIR delivers its little pulse because it's found movement, what I've done is optionally have the beeper go just beep, just. It's fairly quiet and it's very short, and it's good for debugging. Whether or not it stays on in real life or whether it just drives my mum mad, I don't know. We're going to have to find that out. But the exit beeper we definitely need, so that as she leaves the apartment, she touches something, a little round disc, and you'll get 30 seconds or whatever to leave, and whilst that's going, it just won't accept any more PIR movements or anything else. In fact, after the exit has happened and it's gone quiet, the PIR serves to deactivate it again should there be any movement. So that's all very nice, self-resetting. We need an LE flasher because the one on the Wemos board is now covered by other shields. You can't see it. So it was a bit of a shame. I thought it'd be nice to use that LED, so I've just brought it out on the same pins, use the same pins and everything, but just got a separate LED for that. You'll see that working as well. Power in. Now, if you use the USB input, as I said before, sometimes it just won't start up because it needs quite a surge of current initially to connect to your Wi-Fi and things like that. And I found that certainly on my machine, the USB just isn't powerful enough. It needs to be a powered hub or something like that, I think. So I thought, no, we'll have a little a power in shield for that, which you can buy, and it works wonderfully well. And you need an SD card for parameters. Now, the SD card for parameters for things like SSID and password and things like that is a no-brainer, but also this thing like beeper exit delay. How many seconds do you need, or rather does my mum need, from the time of pressing it to get into the front door and shutting it? Well, I don't know. I've just guessed at sort of 30 seconds. I don't know how quick she walks. She's not that quick. 30 seconds might not be enough. It might be 40 seconds is much more sensible, or 50 seconds. So that's on an SD card as a parameter that we can just tweak in text It's just a standard text file. We can edit it and it'll immediately reboot it and it'll immediately pick it up. But there are loads and loads and loads of parameters on there. There's probably a good dozen on there now. Things that you think, I don't really want to hard code that value. What else can I do? Things like the ThingSpeak channel and the ThingSpeak field number that you're using, things like that. You know, it's all those things you just don't want to hard code. The object is never to have to recompile the program unless you're changing the functionality of the program. Okay, now that's pretty much it, apart from one little thing which I'm thinking about ahead, really. Thinking about the layout of Mum's apartment and all that, and I think, yeah, what we might need, and I'm hoping not, but we might need a remote sensor. Because where the sensor, the Wemos sensor is going to be, the PIR, might not be enough to cover all bases. I don't mean it's going to cover the entire apartment. It was never designed to do that. It counts, you know, movement over a period, which is also on that SD card, by the way. You know, how many minutes in a period are we going to allocate in which we count individual movements and then determine, yeah, that's fine. You know, if there was 10 movements or 4 or 28 or whatever, that's all in the SD card. But if it doesn't cover it, because she's, I don't know, been in the kitchen for, you know, an hour or two making cakes or whatever, which she does even at 91, I think, well, maybe we do need this remote sensor. Or 2 or 3, I don't know, but I'm already thinking ahead, and I'm thinking NRF24L01 perhaps, which I covered in a video previously. It's simplicity itself to implement, but I haven't got time to do it this time around, but I might have to do that for when I go back later this year. So that's it. Now I'm hoping we don't need that remote sensor. I hope it just works the way it is without that, but we'll see. I'll let you know when I come back. So there we are. That's a general overview of what it looks like. Ah, you're back. Right, now ThingSpeak then. What does it look like? Well, if we have a look at the browser, here we are. This is my live ThingSpeak channel, and this bit over here is data that's actually being collected as we speak from my mum's flat. So I upload every 15 minutes, which is what each one of these little red dots is. The value it's uploading is how many activity events did I record in the last 15 minutes. And you say it's 3, 5, 2, there's a 0, 1, so it's pretty low stuff, although this morning look, she was much more active, 25, 25, and I've got this set to a certain number of hours. You can do it for days, weeks and months. Now that is fine and it's useful, but not as useful as the app that I have on my phone. So shall we have a look at what's the data look like on my phone, which is a free app from Google Play. I didn't have to write it. I thought I would. I don't. So let's go and have a look at that now. Right, so this is the app in the center of my screen here. It's a widget, effectively, that sits in the middle here. I'll put the details of where I got the widget from, free from Google Play. I've got it set up so that it displays the activity in the middle, which I think it does automatically. But see that little graph symbol down there? That will switch to that same graph that we just saw on the web. So if I touch that, right, now that's charting what a custom chart that I've got down here, which I've got for I think it's like 8 hours or thereabouts. So there's the bit where she went out. This is activity, where she's obviously doing quite a lot of activity. And this bit down here where it's all zeros, that was overnight. Okay, so it still monitors, but obviously because there's a quiet period that I've got as a parameter to this entire module to say between 11 and 7, don't notify anybody about anything because it's sleep time. So yes, it still monitors on ThingSpeak every 15 minutes, and then there she obviously woke up. Now this also displays little data points. Bit difficult to do with my phone. If I touch one there, look, that one up there, activity 25, that's obviously capped down here. So this morning she was up and about already at 6:28. Pretty good, eh? So as you can see, this is a really good way of monitoring activity to make sure everybody's okay, but it's not intrusive. I don't know what she's doing. I've no idea. All I know is that she's moving in that area of the flat, the apartment, and everything's all right. If this afternoon this were to go, or any time this was to go to 0 and stay there longer than 90 minutes, so that module would say, right, I'm going to detect now whether there's been sufficient movement over the last 90 minutes, and it would add up all these points that make up the last 90 minutes, and it go, well, there's been 4 movements, and you've said a minimum of 5. So I'm going to send you an email to say check it. Well, checking it is 3 seconds work, isn't it? Just look on here, and this is always with me, so that well, I can check the activity anytime I like. Now, it's not just me that's got this. There's people over in Germany, family, brothers, people like that, who are also monitoring it, and I think it's an excellent way to go. Right, some more information about the actual hardware on here then. As I say, these are all Wemos D1 Mini modules, and they all plug into each other. You can get loads from places like Banggood. That's where I bought mine, because it's quick and they were cheap. Let's have a look on the browser, see what there is. So what I did in the search box, I just typed in Wemos D1 Mini, and as you can see, lots of stuff came up. The bits I'm using are the tripler base. Well, we'll come on to that again in a minute. So that allows you to plug 3 things in the base there, look. And you get a selection of headers and sockets and whatnot, so you can decide whether you want things to plug into that unit, you want to plug that thing into other units, or both. Okay, what else? There's oh, you can get 5 of them. They're obviously a lot cheaper if you buy 5. I probably bought that many because I was playing about quite a bit. There's modules that actually do things like the SD card. I bought 3 of those. That takes that tiny little mini SD card, and it's great for parameters and stuff. Why didn't I use EEPROM? Well, it's just a lot easier to stick an SD card in here and whip it out again and put it into a PC to edit the parameters than muck about with anything in EEPROM. And what's this last one here? Oh yes, these are the little tiny prototyping boards then. So you can build your own things on here and use any one of those headers, as I say, to connect to other modules. Now let's just go back to this tripler base. Oh, there's a doubler as well, it does as well. Okay, the tripler base, which is this one here. Now I had trouble with this prototype, the one on my desk at the moment. The one that my mum's got is a slightly improved one. So let's think about what the problem was and how I overcame it, thanks to JLC PCB. So the base of this entire module down here is one of these. Right, this is a Wemos triple, there it is, Wemos tripler base version 1, blah blah blah, and as I say, they're $2.23 from Banggood as we speak right now. And that sort of worked okay, except I noticed that the connections between these modules wasn't particularly stable. You'd only got to move something and suddenly the screen would disconnect, for example, it would start beeping. And I think, what is going on? So there were 2 problems. One, the soldering on those headers was not particularly great. What headers? Let me show you. So this header here, which is the ones you poke through, this is in fact from an Arduino, so it won't fit in here. There's too many pins on it. But if I just put it through here as an example, so that goes through all the way, sticks out the other side, which means you can plug further modules in this side and plug this into receiving sockets on the underneath. If you've got a Pi or Raspberry Pi or even Arduino shields, of course, plug into things like this, don't they? So it's all very flexible. But what I found was the soldering of these pins, so these brass pins to these little pads, was poor, and there were a number that weren't soldered correctly. Now, yes, we can all make mistakes, but I've been soldering for a long time, you know, through hole stuff like this, and it was just not good. I had to redo quite a few, because when you discover one problem, you think there might be others, so you basically have to resolder the whole lot again. So I was unhappy with that, for one. And secondly, because this board, it must be one of the thinnest PCBs I've ever seen. Look how thin that is. It's certainly not 1.6mm. This must be 1mm at the very most. And what happens is, if you look, I can bend it. And because I've been playing about with it a long time on here and pushing things in and out and turning it upside down, basically abusing it a little bit, I was worried that maybe some of these interconnecting tracks on here were now damaged and split. You can just about make out the tracks, look, in darker blue on here. Now I don't know how much flexibility they've got if you bend the board like that trying to get it out without even realizing you're doing it, but I just thought, yeah, it's all a bit worrying, given that if this board goes wrong, I'm not around to fix it, okay? But my mum certainly wouldn't know what to do. So I went to JLC and I said, I'd like to do a better board, and they said, yeah, go ahead. So here it is. This is the triple base, almost a copy of this one. The only difference I made was I moved the 5 volt from down here, which is pretty inaccessible, frankly, and I've put it at the top now, this row here, where you can get hold of it. Although, ironically, I'm not sure I actually use 5 volts anymore. But the best thing about it is, of course, it's a decent 1.6 millimeter thick, and this does not bend. Look, I mean, it's if I bent that, it'd probably snap the entire board. So that is solid, and I'm really, really pleased with it. And that's what my mum's got in a flat as the base board underneath all these. Now, obviously, I can't change the PCBs on things like this, but I don't think they need to be either, because they are modules in their own right, like this one here, the power one, for example. Now, I've soldered the wrong headers on here to be able to plug it into something, but as you can see, it's small, it's all soldered up nicely. There's nothing to bend or flex on it, quite frankly, so I haven't had a problem with the power socket at all, apart from, as I say, these header things. So I've made the current one with this, and it's all working okay. But I did think, okay, I want to improve the sensitivity of that PIR. That PIR is okay, but because her flat is sort of open plan arrangement, she can be sitting quite away, good 6 meters away perhaps. I don't know, is it 6? Probably less, but whatever. And this won't detect, that won't detect her sort of waving her arms about. She has to actually stand up and walk towards the kitchen before it detects her. So I thought, I wonder if the bigger ones detect movement easier. So I've been experimenting with one like this. You can see it's physically bigger, well, the plastic bit on top of it is anyway, and it's also got adjustments here for sensitivity and the time it stays on for. So I've been playing about with that, and yes, it does have a better range. Unfortunately, the pin arrangement, would you believe it, is not the same as that one, so I can't just extend these pins using some DuPont cables and plug it in. I'd have to create a whole new board to do that. So I thought, not something I can do very easily remotely. But I do want to build this again for when I go over in October. And I thought, well, if I'm going to build that middle bit again using one of these, and perhaps make a few other changes to this as well, fundamentally it'll stay the same, but there might be a few changes. Like, look at that wiring, that looks a bit untidy, doesn't it? Why don't I make a better board? So this hex base is basically 2 of these. The design anyway is 2 of these. Well, if I turn it around the right way, the other way. Right, so it's 2 of these like that, just one there and one there. Now you might think that'd be pretty easy to do, because I did it in Easy EDA, and of course, yeah, it's fine to put 2 like that. But all these pins are connected on this board. As you can see the yellow traces connecting, you know, all these pins here are connected to all these pins here. And similarly, all the ones here are connected to all the ones here. You get it? So they're all running in parallel. So for a triple, that's okay, because you do one lot on the top and then you do another lot on the bottom and everything's fine. And that's really easy to do and great. However, once you put 2 lots like this, it suddenly becomes very difficult, because you've now got to connect all these pins here to these ones here to keep the continuity going, and all the ones on this side down here. So there's 2 ways of approaching this, and I've done it both ways just to show you. You can probably just about make out there, look, tracks on the outside of this board now, all coming from those pins at the top, running down, then diving through the board via little tiny veers, and then joining up to these pins here. And I thought, okay, that's not a bad way of doing it. I've seen computer boards doing similar things, you know, big long buses of wires. I thought, well, I can do the same here, but I can't. Why? Let me show you. I'm building this device onto this coaster. It's a plastic coaster, look, with little tiny feet. And it looks very nice. It's sort of smoked grey. It looks nice in real life. But this board now is as wide as I can possibly make it. I mean, and fit nicely. So if I was to try to extend this side the same as I did that side, it's just, well, it would just fall off the edge of the board. So I was a bit stumped really, and I tried to think, well, would it be better if I just did 4 of these together and put them in the middle and not make 6? And I thought, well, that's hardly worth the effort. And then of course it occurred to me, that maybe having an extra layer inside, so sandwiched inside here, is effectively another board. I can run traces now from all these wires through that middle trace down to here, and that's exactly what I've done. So this side is all connected internally inside this board, and you don't see the traces at all, which is a bit spooky really, because I know they are connected. I've done a test with a multimeter just to make absolutely sure, and yes, they are all connected, whereas this side here you can see the traces just about. Yeah, it's a bit spooky having these on the inside. Now, being matte black, it looks, I think this board looks really good. Oh, by the way, JLC PCB do the same colour, this matte black, for the same price as green, yellow, red and all the rest of it. It just takes a little bit longer to make. But if you're prepared to wait another day or so, you'll get a matte black board as well. I think it looks pretty good actually. And it's only aesthetic. There's nothing different about the board itself. It's just the solder mask they use on top. Anyway, so I've left it like this, and I've left this side exposed so you can see how the traces run down there, and all these little tiny vias that go through the board to this side and then connect to the pins. You can just make them out there, look in the light. That's one way of doing it, but this side, as I say, it's like magic. They're all inside here somewhere, and I'd have to go back to the EasyEDA PCB designer to find out exactly where I've routed them. Not that it makes any difference, I can't do anything about it now. So that's my hex base that I intend now then. I intend to put this on this board, to mount it on the board as I did before with little spacers, and they're nylon hex spacers, look very nice. I've got some pictures which I'll show you in a minute. And then space these out a bit more. So rather than being stacked up like this 1, 2, 3 high, it probably only has to be 2 high. So there'll be stuff here, and then 2 high, and then another one of these boards on top, so that it's like sandwiched in between, and it looks all right. Well, it looks very nice in my humble opinion. However, we still have the problem of these horrible connectors not connecting particularly well, and as I say, I don't know the reason for it, but they didn't want to solder well. So the fact they didn't want to solder well makes me think, well, they're not connecting well either. So what I might do is abandon these and actually solder things, all 6 modules, directly to this board. So not to use this prototyping area at all in here. Just forget about that. Solder those boards directly onto here, using not these, but standard header pins, which you can just make out in there, look, in this little pack. See, there's standard header pins. This, incidentally, is a pack of one of those development boards with all the different headers they give you. So that's my options, and I've got until, well, September to do it, so I better get my skates on because it always takes longer than you think, but at least the code's done. So the code, we did have a brief look at various bits of it over the last few months. I'm going to load this into my GitHub, the code that is, and you can have a look at it. I'll take out any personal information in there, but I'm not going to walk through it all because it's about 2,000 lines now. It's quite a bit. And I almost considered rewriting it for ESP32, because as you know, ESP32 is more powerful, dual core, means I could create tasks. One of the things that this does, as an example, is when it uploads, the date time display stops displaying, or it freezes I should say, because this is doing something else, isn't it? So it can't possibly update this whilst I've asked it to update stuff to ThingSpeak, because it's busy talking to ThingSpeak, and there's nothing I can do about that. Now that's only aesthetic really, the fact that this stops and then comes back into play again, that's not an issue. But whilst it is uploading to ThingSpeak, it's not taking into account any more movement. It's not doing anything apart from talking to ThingSpeak at that point, or indeed sending an email. It can only do one thing at a time, and these things take a little bit of time, so everything else stops. Whereas if that was an ESP32, I could do them all at the same time effectively. In fact, some of them I could do at the same time if I put them on different cores, but I doubt whether I have the time to do that. Right, what's next? Pictures. I promised you some pictures of whilst I was constructing it. And I believe this is the original prototype, but with the yellow board. So you'll see it pretty much how it was being built for my mum's flat. So here are the pictures coming up. Right, I've only got a few pictures in fact. This is the underneath now when I first started to make it, and that's the same picture from on top. From the front, this is where the middle bit is where the PIR plugs into, and on the left hand side there is where a little beeper plugs into. Pretty cool, right? And of course it works, that's the main thing. And don't forget, send me your username that you've registered with JLC PCB, and I'll forward them on to my sponsor, and you'll get a $5 discount off your order. Also, don't forget, if you place an order with JLC, you also get a discount off lcsc.com components warehouse. You've got to read up this stuff on the website, and it will all be in my GitHub. So there's plenty to see, do, have fun, and 4-layer PCBs, not as difficult as you might think. I might discuss that in more detail in a future video, exactly how I did it, but I think we've done more than enough for now. Okay, if you'd like to leave a comment, please do so. If you think it's worth a thumbs up, please do so. Don't forget to read the GitHub, because there's lots of stuff up there that I haven't got room for in the video description below. And thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.